Stanford University.
Okay, well, welcome to CS 193P, Winter 2015. This is lecture number 3. This is going to be all demo today. My voice is mostly recovered from last week, not 100% as you can tell, but it's getting there. So what we're going to be doing today is a demo. We're going to extend our calculator a little bit. We're going to make it more powerful, but more importantly, we're going to have it obey this MVC design paradigm. Okay, so it's a pretty good example of showing how we're going to separate the stuff into the camps here. And we're going to cover a bunch of other things, language features and stuff, as I always do. That's really the primary goal of these first 3 lectures worth of demos. It's just for you to see it in action, because you can read all you want about Swift or about iOS, but until you actually see it turning into an app, it's not real. So I'm just trying to make it real for you. I'm going to go to my last slide, because once I go to the demo, I'll forget to come back, which is just what's coming up in this class. On Wednesday, it's going to be no demo. It's going to be all slides. It's going to be one of the few lectures where it's all slides. But what I'm going to try to do on Wednesday is give you the highlights of all this reading that you're doing, okay? Because you're reading a lot of stuff, and it's sometimes hard to tell what's really important in there and what's not. So I'm going to kind of give you the highlights, and so you can get an idea of what's important. And then I'm also going to start talking about some of the foundation layer API in iOS. That's the non-user interface layer, basically, and kind of what some of the classes are in there. And then also just a little bit of how we use the language features of Swift and Foundation in iOS, so that you kind of get it's kind of next Wednesday's lecture. This is going to be your baseline lecture. It's going to kind of get you grounded in how to do all this stuff. And then next week we'll start diving in to building more sophisticated iOS applications. Okay, I know this is kind of a whirlwind first 2 weeks. You're learning a new language, a whole new system, but hopefully by the end of this week and the end of your second assignment, which will go out on Wednesday, you'll be pretty confident that you at least have a solid ground foundation to build from. No pun intended there. There's a holiday weekend this weekend, no Friday section and no class on Monday, and so we'll resume next Wednesday. And the primary thing I'm going to do the next Wednesday, not the day after tomorrow, but the next Wednesday, is talk a little more about auto layout, because you've only just seen kind of a glimpse of auto layout so far, and I haven't even really told you how to do auto layout. And so you're kind of just fumbling around and kind of trying to reproduce what I do. So next Wednesday we'll talk about how to really do auto layout and all that. Okay, any questions before I dive into this demo? Hopefully my voice will hold out. I can already hear it starting to not hold out, but we will see. All right, so I'm going to just go to Xcode here, launch Xcode. And we're going to leave off right where we were last time in the calculator. Here it is right here. And so here's our UI. Hopefully you recognize that and you just did your homework, I hope. And here is this area that I selected at the end, which is this area that's really this is not about how the calculator gets presented on screen. This blue area is about how the calculator is a calculator. Okay, this is where all our calculations are. And this blue area really shouldn't be in this class, this view controller class, because this is the C of our MVC, okay? In our MVC, this is the C, this is the V, the view. These are the minions that this controller is using. And today we're going to create the M, okay, the model. The model is going to be what our application is, which is it's a calculator. Okay? We're also going to enhance our calculator. The primary new feature we're going to give our calculator is that our calculator's model is going to remember every operand and operation you ever ask it to do. Okay? So right now, as we do operations, we consume all the operands. Okay? They consume, they're gone. So in this case, we're going to actually collect all the operations and operands in a stack. And then we can ask the model to evaluate that stack of operations and operands at any time we want. And the reason we're adding that ability is because of your homework, assignment number 2. You're going to add 2 major features where having all the operands and operations in a stack is going to be really valuable to you. So you'll be starting your second homework with what I do today, because you'll need this capability to do what I asked you there. Okay, and I'll talk about that at the end. If I forget to talk about that, remind me. Say, tell us about assignment 2. Okay, so how do we create a new class? Because we're going to put our model, okay, the calculator, kind of get its guts in a different class. So how do we create a new class? In Xcode, we do that up here from the File menu. We go New File. So you're going to do File menu, New File for a lot of different things you're going to add to your project, not even just new classes or whatever. But when you click that, you're going to see there's a lot of different things you could add. And we're in iOS, so you're going to click on this iOS thing at the top. And we want to add a source file. And over here, we're going to be doing this later in the quarter. This is how we basically add subclasses of iOS classes, Cocoa Touch classes. But we're going to do today this one, Swift file. You can see this as an empty Swift file. And since our model is completely UI independent, it doesn't inherit, it doesn't subclass any iOS class or anything. It's just a basic Swift file. So I'm going to pick on this Swift file, click Next. And now it wants to know the name of it and where we want to put it. And we're going to put it in the same place that all our other Swift files are. Here's our controller. And this app delegate, we moved it out of the way at the very beginning of the very first lecture, but it's in there too. So we want to put it in this same directory. And we're going to call this new class Calculator Brain. Now, you don't have to have the name of the Swift file here be the name of the primary class, but we always do that. It would be kind of confusing to people a little bit if the name of the Swift file was different than whatever the primary class is in there. But it's certainly legal, all right? In Swift, the name of the file really doesn't mean anything. It's what's inside that matters. But Calculator Brain is going to be the name of our class, our model. I'm calling it that because it's the brain of our calculator. I'm trying to pick a descriptive name. Notice the capitalization here. Types in Swift, we always capitalize them. And we do not put underbars and other stuff in there. Okay, we use what's called this camel notation here, where every word gets capitalized, including the first word for types. Everything else, we don't capitalize. So property names and things like that, function names, those always start with lowercase. They still do the uppercase of the other words. That way, in reading our code, we can really quickly pick out what's a type and what's not. Okay, so please adhere to that. If you don't, you're going to look like a noob out there. Okay, Calculator Brain is what we're going to call it. I'm going to create it. Here it is right here. I'm going to make it my whole screen. You can see that the import here is not import UI kit, it's import foundation. Foundation is that layer, that kind of core services layer I talked about in the first lecture. It doesn't have any UI stuff in it, which is good because our model is UI independent. So there should be no UI in here. So we would never be importing UI kit into a model class. Okay? Feel free to stop me, by the way, if you have any questions. All right, so we're going to create a new class. You already know how to do that. We just type class, and then the name of the class is going to be Calculator Brain. Now, this class is not going to inherit from any other class. Okay? It's just going to be a basic Swift class. Now, sometimes your model might inherit from a class called NSObject, and I'll talk about that a little later, maybe on Wednesday even. You'll get a little bit if you inherit from NSObject, but we're just going to have it be a basic Swift base class. Okay? It doesn't need to inherit any functionality. Okay, so what's going to be our data structure of our calculator brain? It has to be a little different than the data structure we used in our controller to capture the operands, because we've got to capture operations and operands both into this. So we want it to be a stack. I'm going to call it op stack. But the type can't be array of double, okay? Because operands are doubles, but operations are like a combination of a mathematical symbol, like plus or times, and then also a function that actually does the thing, okay? So obviously we can't do that. So we're going to have to need some new data structure. I'm going to call that data structure op, and we're going to define that in a second. So op is going to be something that could be an operand, or maybe it could be an operation. Okay? It can be either or. Okay? Now, a couple of things about this here is, of course, I have to initialize this, so I'm going to do the exact same thing that I did in the controller, which is I'm just going to create an empty array of op. Okay? And I'm even going to use a little different syntax. Okay? We've been using this. I like this syntax because, especially for people who are first time to Swift, it's very clear. This is an array, and inside the array are these ops. But this is evidently not the syntax that is preferred. The preferred syntax is actually to do square bracket op. Okay? So this is just an alternate syntax, putting square brackets with the type in the middle, for declaring an array. It's exactly the same thing. Just a different way of typing it in, identical in every possible way. It's exactly the same. Okay? I think this is a little bit preferred because if you ever initialize an array, which we'll see later, you use this syntax to create the array and put things in it. So I can understand why they do that. Okay? So this is an array of op. That makes sense? Now, let's talk about op. What kind of thing should op be? Well, we could make op a class. An op could have a property for an operand, which would be the value of the operand. It could have another property, which is the symbol, mathematical symbol for the operation, and another property, which was a function, which does it. And obviously, if the operand is set, then the other two would be not set, and vice versa. But that's a little bit weird to have a class that has properties that sometimes are set, and if other things are set, they're not set. It's really not what we want. What you really want is an enum. Okay, so you're probably used to enums in other languages, so I'm going to create an enum. It looks very similar to creating a class. I just used the word enum instead of class. Obviously, no inheritance for enums, sorry. But enums can have functions, just like a class. They can also have properties, but only computed properties. Okay, they can't have any stored properties. So, you know, enums are kind of for basic types, and enums are really great when you have something that can be one thing one time and a different thing another time, and never both at the same time. That's kind of what enums are, right? They're enumerating different possibilities. So we could say, you know, case operand, and we could have a case operation to have the different things that we have. Now, in other languages, this would be as far as we can go, and this would be pretty useless, because if we had an array that just said whether it was an operand or an operation, that doesn't help. I need the actual operand. I need the operation's mathematical symbol and its function. I need them. They have to be in this enum. And Swift has a really cool feature where you can associate data with any of the cases in the enum. So for an operand, I'm going to associate the data double. So if my enum is an operand, it'll have this double associated with it. That's going to be the value of the operand. And similarly for operation, I'm actually going to do unary operation first. That's a single argument operation. I'm going to have a string, which is going to be the symbol, the mathematical symbol for it. And of course, I'm going to have a function. Okay? Again, functions are just types in Swift. It's no different than string. Okay? We're just saying this is a function. We put a function in there. A lot of times we'll do the curly braces and put a closure, use closures to create our function, but we could create actual functions and pass them in there. It's fine. So, and we'd also want a binary function here too that takes 2 arguments. Binary operation, and just has 2 arguments here in its function. Okay, so now we have a stack, okay, which is an array of ops, and these ops are each op in this array is either an operand or it's one of these 2 kinds of operation. Okay, so so this is great. We got this op. It's either an operation or an operand. How are we going to, you know, put things into this op stack, for example, and stuff like that? So let's go talk about the API. API stands for Application Programming Interface. API is kind of all the methods and properties that make up your class, the description of them. So I can use that word a lot, API. And we really need to be able to put an operand on there in the stack, and we need to be able to put an operation on. So I'm going to have a function called push operand, and it's going to take an operand, which is a double. Okay, it's not going to return anything yet, anyway. And to push an operand on my stack could not be easier. I'm just going to say op stack append. You'll remember that append is a function in array, and the thing that you put on obviously has to be this little type T. T is whatever you put in here, so op in this case. So we obviously have to have an op here. How do you create an enum? item, you just say op dot operand, and you give it the associated value. Okay? So very simple kind of way to create these enums and associate the value with them. Any questions about that? Okay, and then how about operations? We'll have, instead of push, we're going to call this perform operation. And I think when I do perform operation, what I'm going to have is my calculator brain is going to have a bunch of known operations, things it knows how to do. And when you perform an operation, you just specify the mathematical symbol of it. So the argument here is going to be symbol, which is a string. Okay, so to append an op on here with an operation, I'm going to need to have these known operations. So how am I going to do that? Well, to have known operations, I'm going to create another instance variable here called known ops. It's my known operations. And it's going to be a dictionary. Okay, now you read about dictionaries in last week's reading assignment. That's why I have the reading assignment due today, because then I can know you've read about them. I hope you have. And so how do I create a dictionary? It looks like this, dictionary. And it's the same kind of thing with these angle brackets, because you have to say for the dictionary what type are the keys, what type are the values. And our dictionary is going to have keys that are strings, and it's going to have values that are ops. Oops, sorry, ops. Okay, and I'm going to create one. Okay, everyone understand this? Now, this known ops, I'm just going to put all of the ops that I know in there, where the key is the symbol and the value is the actual op. And then when someone says perform operation, I'm going to look it up in the known ops. And when I find it, then that's the operation I'm going to push onto the stack. Right? Makes sense? But I have to load this known ops up. Oh, well, first of all, so let me talk about this syntax. Just like array has a special syntax with the square brackets, so does dictionary. So to have a dictionary like this with this kind of special syntax, we're going to do open square bracket and then a colon in between the key and the value type. So it looks like that. So it looks very similar to array, but you've got this thing where you've got the key and the value separated by a colon. Okay? Same thing though, exact same thing. Just a dictionary, strings, looking up in strings to find ops. All right. So how am I going to initialize this known ops? Well, this is a great time for the first time for you to see an initializer. Okay? So far we've been creating classes, like right here, okay, just by putting these parentheses. And I told you that was calling an initializer in dictionary. Okay, and this one was calling an initializer in array. And so we're going to have our own initializer in calculator brain. And we just do that by saying init, like this. Okay, now anytime someone says something like let brain equal calculator brain with the parentheses, okay, it's going to call an init that matches the same arguments. In this case, no arguments, so it's going to call this init. Okay, couldn't be simpler there. So what are we going to do in this init? We're just going to initialize this known ops. I'm just going to start putting some known ops into this known ops dictionary. We need our friend special characters here for that. So let's go ahead and put let's put times here first, I guess. Okay, and we need to create an operation. How do we create an operation? Very similar to how we created this enum, op dot. And times is a binary operation. And you can see it's typing this for me. I'm just pressing tab to get along. This is the symbol, which is this thing here. Now, it's kind of bad code that I'm ended up typing this twice in the same line. If I accidentally use the wrong X, like some X from somewhere else, or the X just from my keyboard might be different from this X, then this X, we could get in trouble where these things don't match up. So later, right at the very end of the demo, I'm going to show you how we could do this in a way where we don't have to type this X twice like that. Okay? But now we just need the function. We know how to do that with closures. I say $0 times $1 and the closure. And yes, I could put this closure outside since it's the last thing here. That is also legal to do when you're creating the operations like this. Okay? So that's kind of nice. Let's do our other 3 binary operations here. We'll go divide. And this is where it really gets annoying to have to type it twice, but I have to show you something else before I can show you how to do that right. Let's go here, and then we have minus. You can see there's two different minuses there, so hopefully I click the same minus in both those spots. And then we change these things. We know that divide is 1 divided by $0, and this is plus, and this is 1 minus 0, $1 minus 9, 0. Okay? So everyone cool here? These enums are really easy to create. The API of them is really, really nice, simple. And then we have our other operation, which is our unary operation, which is square root. So let's put that in here. Square root is right here. And we'll put it right here. And square root is not a binary operation. It's a unary operation. Oops. Get all this. Okay. And, of course, inside here, it's square root of $0. Okay, you remember that from last time. So this is good. Now, while I'm here, I want to show you a couple things more about closures. Okay, what is this curly brace? It's a function that takes one argument and returns one argument. And we know that it's doubles because we're creating a unary operation, and so it's inferring the type here, right? Everyone understand that? Well, there's another function that returns a function, or so there's another function that takes a double and returns a double that does square root. It's called square root. So inside here, we could just say square root. Okay? We don't even need this business. Just want to emphasize that we're just passing a function here, and it can be a named function, or we could use these curly braces. Now, this is really going to freak you out, because watch this. For times, there's a function that does times called times. Okay? So in Swift, all these operators, times and all these things, are just functions. They just happen to be specified in a way that says they can infix, right, between the two arguments instead of taking the arguments in parentheses. And we do the same thing here with plus. Right? Plus. Now, we can't do it with divide and minus because the order is backwards. Right? We put the things on the stack, we put them out, pull them out backwards. So we can't do it with those. But I just want to emphasize that that's what's going on there. Okay, so now we have this nice known op. So we have this thing, it's loaded up. It gets loaded up whenever the calculator brain gets created. So that's all good. Now we can use that down here in perform operation. All right, so how are we going to use this in perform operation? Well, we basically want to let the operation equal known ops sub symbol. Okay, someone passed us a symbol. They're trying to perform this operation. So this is either a plus or times, hopefully an operation we know. And we're going to look it up in known ops. And the way we do that is with this subscript notation with the square brackets. Okay, that's how you look something up in a dictionary. But what might be kind of surprising to you, what type do you think this would be, operation? Any guesses? Yeah, some people are saying the right thing. You'd think this might be an op, because I'm looking up in known ops right here, a string. And so hopefully I'm getting an op. But this is not an op. This actually is an optional op. Okay, now why is that an optional op? Because you might be looking up something that's not in there. And it has to return, oh, nil. Sorry, couldn't find it. So that's why it has to be an optional is returned. So dictionary, whenever you look up something in a dictionary, it always returns an optional. Okay, either nil or the type of thing you said was supposed to be in there. So I'm going to if let here. I'm going to say if I'm able to look up my operation in my known ops, then I'm going to push it onto my op stack. Okay? Everybody cool with that? Make sense? Okay. Now, what's next? Well, now we have, I'm going to take a pause here to talk a little bit about access control. Okay? Access control is about public and private. Okay? What methods in this class are public? In other words, other people can use them. Other classes in my code are allowed to call them. And what things are private? My internal data structures that I don't want people messing with. Okay? So the way public-private works in Swift is kind of interesting. You basically specify the things you want to be private by putting the word private on them. If you don't put any word on them, then they're public inside your program. Okay? And you only use the word public if you're shipping out like a framework of objects to other people, and you want stuff in there to be public outside the framework. So I'm making some framework, a bunch of objects that I'm trying to sell to people or to get people to use to do something. And of course, I'm going to have things where my objects inside my framework can talk to each other. There's no keyword needed for that. Then I'll have things inside certain objects that are private, only to that object. I'll say private. And then some of them might be public that the customer who's buying my objects, my framework, can use. Now in this class, we're not going to be doing frameworks. We don't really have time to get to that. So we're not going to be using the keyword public. We will never use that because we don't have any frameworks. But we are going to use private. And starting with assignment 2, it's one of your evaluation criteria is going to be make private things private. Okay? So that is important to do. And you could just say, well, I like everything to be public. Well, that's bad. Okay? If you make your internal structure public and some other object in your program starts mucking with it and breaks your object, and then you come to a new version of your program and you change something and now everybody's breaking, that's bad. Okay? That's chaos. So the only things that want to be not private are things that you're committing to sign up to support. So in this class, the only public things so far are the initializer. Obviously, we want to allow people to create a calculator brain. That's clearly public. Also, pushing and performing operands and operations, that's public. Okay? Everything else, for now, I'm going to make private. So I'm going to make this private. Notice that if I make this private, it's going to start saying, whoa, wait a second. This can't be public. You know, it can't be non-private because this is private and it uses it. That's what this warning is going to say right here. See, property must be declared private because its type is private. Okay, this type this. But I want this to be private anyway. This is my internal data structure, op stack. Now, known ops is kind of an interesting one. Maybe I would want that to be public one day because maybe I want people to use my calculator brain and teach it new ops. That wouldn't be that unreasonable. However, I'm not ready to support that functionality in my calculator brain. I'm just not sure I want to do it this way. Maybe I don't want this property to be public. I might want to have some functions to learn an op or something like that. So I'm just not sure. So I'm going to start out private. And that's really, when you're designing APIs, you want to kind of start out, make it private first, and then open it up as you're willing to support that functionality. Question?
Is the common view in Swift to make most instance variables private and use getters and setters, or is it to make them, if they are supposed to be public, or make them public and then let the...
All right, so the question is it kind of part of the Swift way to make most instance variables private and then have getters and setters that are public to get them? That doesn't really even make sense in Swift. That's more of an Objective-C thing. In Objective-C, you had instance variables, and then you had properties that would get and set them. In Swift, it's kind of merged those a little bit closer together. So that properties are really kind of the public or private getters and setters. So if you have a property, you just have to decide whether you want people to access it or not. And if not, make it private. And if so, make it public. And that, you know, don't make it non-private, basically. And that's all you need to think about. I wouldn't even think in Swift in terms of instance variable versus the property. Now, it is still possible in Swift to do that because you have computed properties. And those could be setters and getters that are setting private properties. But we're going to see on Wednesday even, I'm going to talk to you a little bit about a way that when your properties get set, you can intervene. You can check them to make sure the value is okay. So if you have a public property, you can still protect it by intervening a little bit when people set it or try and get it. So it is possible to still have some protection there. We'll see that. All right, so these are our only public things. Now, there's only one other public thing we need to do in our calculator brain, which is we need to let people evaluate this stack. So people are pushing operands and performing operations. Now they want to know what's the result. Okay? They pushed an operand of a 5. They pushed an operand of a 4. They performed operation plus. They want to see 4 plus 5. Where's that 9? Okay? They need the result. So we need another public method here, which I'm going to call evaluate. Okay? And evaluate could have it return a double, for example, and it would just evaluate this op stack and return the value. But I really can't make this a double. Really, this has to be an optional. Okay, why does this have to be an optional? Well, that's because someone might get my calculator brain, and the first thing they do is they say, perform operation plus. Okay, well, I have no operands, okay, and you're asking me to evaluate plus. I can't do that. So I have to return something to you that lets you know I could not evaluate what you asked me to evaluate, so I'm going to return nil in that case. So evaluate here really needs to be an optional. Okay, so you can see some of the thinking. When do you make something an optional, when not? Okay, so this is a classic case of that, where you've got sometimes you want to return it, and you can't do it, so you have to return nil. All right, so how are we going to implement evaluate? Okay, how many people in this class, raise your hands, don't be shy, are you comfortable with the computer science concept of recursion? Okay, excellent. That's about 80 or 90%. So I'm going to explain this really fast then. And if you don't understand recursion, if you didn't raise your hand, that's something you should go review. Okay, recursion is something you should know by the time you take this class. So that's something you definitely want to know. So how are we going to use recursion to evaluate this stack? All right, looks like this. I'm going to do a sample stack right here. So let's say I put a 6 on the stack, and then I put a 5, then I put a plus, then I put a 4, then I put times. Okay, so here's our stack, and I'm going to evaluate this, and I'm going to use recursion. How am I going to do that? Well, really, what I'm going to do is I'm going to have a helper method here, a recursive helper method. I'm going to call it evaluate also, actually. And it's going to take a stack as an argument, a stack of things to evaluate, and it's only going to evaluate the top thing on the stack. That's it. It's just going to evaluate the top thing on the stack and return it. But the top thing on the stack might involve looking at every single one of these, right? Because this times needs its 2 operations. So let's look at this. This recursive evaluate is going to come in here. It's going to try and evaluate the top of the stack, which is a times. Okay, so it's like, okay, I'm doing times. Now, for times, it needs 2 operands here for times. So it recursively calls itself to say, give me the first operand for times. And so recursively comes in here. It finds a 4 on the top. It's like, I know how to evaluate 4. It's 4. So it just returns. Okay? So now I have my first operand. Okay? Now I take the rest of the stack and evaluate it to get the second one. And when I do that, I get plus. Okay? So plus says, oh, I have to evaluate plus. It needs operands. So I come over here. I'm getting a plus. And I got to go recursive again to go get its operands. I get the 5. That's good. I'm going to go recursive again, get the 6 over here, and I've evaluated the whole stack. So you see how I have to keep going back recursively to my evaluate to get the operands for my operations. Once I get to an operand, I can stop. Okay, as a number, I got it, and I'm out of there. But every time I encounter another operation, I have to keep going recursively to get all my arguments. Any questions about that? Okay, so it's actually going to be pretty simple recursion. When you see the code, you're going to be, oh, yeah, that makes sense. So I'm going to have this separate, I'm going to put this up on top for scrolling reasons. Oops, didn't mean that. A separate evaluate. And this evaluate is going to take a stack of ops as its argument. And why does it take a stack of ops? Because as it's recursing, it's using the rest of the ops. So you see what I mean? It can't be looking at the big op stack in our brain. It can't look at this, okay, because it's kind of consuming it, right? And every time I call it recursively, I'm giving it fewer operands to work with. So this is what I'm doing. Now, the first time I call it, right here, I'm going to give it the full op stack. So I'll call my recursive one from here. Now, what's this thing going to return? Okay, that's interesting. And here's a big new thing for you to see. You've read about it. I can't remember even I asked you to read about this, but I guess I didn't, which is tuples. Okay? So in Swift, you can combine multiple things together into one kind of really mini data structure called a tuple. Okay? Don't let the 2 sound in there fool you. It's not just 2. It's any number. Okay? And you just put them in a parentheses. Okay? And that's it. So you can use this for return values. So I've got a function right here, and I actually need to return 2 things from this evaluate. Okay? One thing I need to return is the result of evaluating it. But the other thing I need to return is the rest of the stack that I didn't use. Because as I'm working my way down here, and I take off that times and the 4 and the 5, okay, I'm consuming things, but then I'm leaving the rest of the stack. So I have to keep returning what's left of the stack so I can keep consuming it, okay? So I'm going to return this in a tuple. Tuples could not be simpler syntax, just open parentheses, not 9, open parentheses, and then just all the types of things you want in here. So I'm going to return a double question mark. That's my result, okay? That's what's eventually going to be returned out here after all the recursion unwinds. And then also, I'm going to have the ops that are left over. Now, a tuple can look just like this, unnamed. You see how these things are not named, each of these things in here? But you can also put names in here if you want as well. So maybe I would call this one the result, okay? And I would call this one remaining ops, okay? And I kind of recommend putting those in there, and you'll see why in a second, because there's 2 ways to call a function that returns a tuple and get the results. And one of the ways requires that you name these, okay? So it doesn't hurt to name them. You might as well. It's good documentation. Someone looking at this now knows, oh yeah, this is the result of the evaluation, and this is the ops that were left over, okay? All right. So let's dive in here. The first line of code I'm going to put in this recursive function is the failure line of code, which is return nil ops, okay? So if I fail, okay, I'm going to try and do my best in here to evaluate these ops you passed me. But if I fail, I'm just going to return my result of nil, okay? And that's going to be my default, is to return nil. So now I know I failed. So if I run out of operands or I run out of stack, can't find it, for example, it's just going to fall out here and return nil. Okay? So that's good. So what do I need to do here? Well, first thing is I need to make sure I have some ops. So I'm going to check to see if the ops is not empty. Okay? If you've handed me a stack of no ops to evaluate, I can't do that. So I'm just going to return nil. Okay? So that's the very first thing. I got to make sure I have some ops to work with. Now I'm going to grab the first op off the stack. So in this example, I'm going to grab that x off of here. Okay? I'm going to do that. I'm going to try to do that by saying let op equal ops. Okay? Ops is this argument right here. Okay? That's the ops you told me to work on. And we know how to remove last. Remember removed last from last time? Removes the last thing off an array. And when we are trying to make an array look like a stack, that's how we do it. Okay, we push things by putting these on the end of the array. We pop things by pulling it out. But you can see I got an error there. And it's very important to understand why I have an error here. Okay, so I'm going to click on it. We're going to read what it says. It says immutable value of type array of op only has a mutating member named remove last. Okay, well this is kind of a formal way of saying you can't do remove last on ops because ops is immutable. It's read only. You cannot mutate it. You cannot change it. Okay, why is ops read only? Well, there's 2 things to think about here. One is when you pass arguments into functions, unless it's a class that you're passing, unless you're passing an instance of a class, the thing you pass is copied. Okay? It's very important to understand that. That's passed by value. You're used to it in other languages. Most languages do this. Passed by value. Arrays and dictionaries are not classes. They're not classes in Swift. They're structs, you know, like a C struct. Okay? Arrays and dictionaries are structs. Structs in Swift look a lot like classes. They have functions. They can even have properties that have storage. They're almost identical to a class, really. The only 2 huge differences between structs and classes, one is that classes can have inheritance and structs cannot. Okay? But number 2 is that structs are passed by value and classes are passed by reference. Okay? Very important that you understand that distinction. So structs are usually only used for basic, you know, components like arrays and dictionaries. Even doubles and ints are structs in Swift, okay? And that's great because that means doubles and ints can have functions on them and things like that, which we'll see as the quarter goes by. But those things are all passed by value. So that's the first thing to understand, is that this ops, when I call evaluate, whatever array of ops I pass to it is going to be copied. Okay? The second thing to understand here is that there's kind of an implicit let in front of all things you pass. In other words, they're read-only. Make sense? And a read-only array can't be mutated. You can't append things to it. You can't remove things from it because it's read-only. Now, I can actually put the word var here. Okay? If I put the word var here, then ops inside here, look, no error. Ops is a mutable array. It's still a copy, though. So they copied it and made it mutable. And now, inside here, I have a mutable copy to work with. Now, I'm not a big fan of doing that, okay, of putting var up here. I think it's a little confusing for readers of the code to understand exactly what's going on there. So I'm not going to do that. Instead, I'm going to make a local variable here, which I'm going to call remaining ops. And I'm going to set it equal to ops. Now, when you set equals like this, that copies it if it's not a class. Classes are all by reference, exactly what you would think. But anything else, structs or enums or anything else, when you do equals here, this is actually going to make a copy of this and put it in here. And since it's a var, it's going to be mutable. Okay? So now I have a mutable array of ops, and now I can say remaining ops, remove the last one. And now I truly do have the remaining ops. I've removed the first thing in there. Okay, everyone understand that little tidbit there? Yeah.
So there's like a unseen let in front of the ops.
Yeah.
Why isn't that let in front of doubles and like ints or strings?
It is. So the question is, why is there not kind of an unseen let in front of all arguments? Pretty much all arguments to functions kind of have that unseen let in there. They're all read-only. Okay? So, and you could put var in front of any one and turn it into a mutable copy of it that you could use locally. But you can only use it locally. It's not that great a thing. Okay? Now, there is a way to pass by value things back out, but I'm not even going to talk about that. Okay? You can read about it. It's this in-out thing. I'm not even going to talk about it. I really think it's better to stay within the value, pass by value and pass by reference parameters. I think we get more readable code that way. But there is a way I'm not going to talk about to do in-out, basically, parameters that go in-out. Yeah.
Is there any way to pass by reference? Because if ops were a huge array, we just copied it 3 times.
Yeah, that's what I've just said. There is a way to pass it kind of by reference, in-out. You know, you pass it in, you modify it, and then it'll come back out when it's done at the end. So that's kind of like by reference. But the other thing you said is, oh, this is terrible. I'm making 3 copies of that dang thing. This must be super slow. And the answer is no. Swift is super smart about not actually copying it until you actually make a change to it. So here, when it passes a copy in, it didn't really copy it. It just kind of passed a pointer in, but it knows that pointer is by, not by reference, is by value. And then when I copied it again here, it still didn't really copy it. Even if this array had 10,000 things in it, it didn't make 10,000 copy of it. It was only here where I actually mutate it. Now it had to make a copy. And it may not even have made an entire copy. It might have just kept track of the changes, for example. So it's super smart behind the scenes. Swift is very smart. So don't worry too much about, oh, I'm copying these things over and over. Swift is making the minimum amount of actual copying going on. Okay? All right, so now I have remaining ops here, which truly are my remaining ops, okay? Because I've removed the top one, the x, off the top. So now I've got all the remaining ops in this local variable here called remaining ops. Okay, now what am I going to do with this op that I pulled off, this one on the top, the x? Well, I'm going to get the associated value from the enum, okay, either this or these or this. And how do I do that? I use switch. Okay, I told you that switch is really important, and now you're seeing that switch is really important. Switch is how you pull things out, associated values out of enums. So I'm just going to switch on the op. Okay, this is the op that I pulled off the top, that x from the thing we did on the board. And I'm just going to look at all the cases. So I have a case operand. Okay, notice that it puts a little dot here because it's really op.operand, and it's using type inference to know that it's op.operand, right? It's op.op op.operand, but it doesn't need the op there. And here it's asking in this space, what do you want to do with the associated value if you're handling this case where the enum is operand? Okay? Well, I want to let that associated value be assigned to a constant called operand. Okay? And yes, I could put var here, which would do the same thing, except for I could then change the thing in here, but I almost never want to do this, almost always let. So let operand means that inside the handling of this case, okay, this case of the switch, inside here, operand is going to have the associated value of the operand. Okay? Ooh, that's exactly what I want. I'm just going to return. Right now, I have to return this tuple right here. So I'm going to return the operand. That's the result. Okay? When I go here and I encounter that next one down, which was a 4, I got a 4. I can just return that result to evaluate this one. And I also, though, have to return the remaining ops. Okay? So I'm just returning the two values of this tuple. Notice I don't have to put result colon and remaining ops colon in here. It knows that those match, and so it's just doing it. All right? Make sense? And that's it for operand. That's all I have to do. It's kind of, in the recursion, it's kind of an end case. Yeah?
Is remaining ops stored on the stack or heap?
This one here or this one here?
Well, in general, are Swift structs like last?
Okay, so the question is, when I do something like this, where is remaining ops? Is it in the heap? Is it on the stack? And the thing is, that's implementation detail. So you don't know, but you don't care. All right, so that's operand. Operand was really, really easy. How about our operation? Let's do unary operation right here. Now, when we handle the case of the unary operation, we don't need that first associated value. That's the symbol, like plus. Okay, well, I'm evaluating here. I don't care what the symbol is. I only care what the function is, because I'm going to evaluate the function. So we can actually ignore this by putting an underbar. Okay, underbar in Swift is kind of the universal, I don't care about this thing. Okay, and we're going to see it other places we use it where it's kind of like, I don't really care about that. So you just put an underbar there. That way you don't have to declare a variable with some dumb name or something like that. Just put an underbar, it ignores it. Okay, but I do care about this. I'm going to let that equal the operation that I'm doing. Okay, everyone make sense there? So I'm ignoring the string, but I'm grabbing the operation. So here, what I want to do is return, and I'll try to do it, but I'm not going to be able to. I'm going to say return this operation with its operand, which I don't have, and some remaining ops that are left over after I get its operand. So I need to do some stuff here to be able to return what I want. The first thing I need to do is get the operand. Okay, so I did a unary operation. Let's say it was square root. I need to go back to the stack and pick off the next thing, but I can't just assume that it's a number. It might be more operations, so I have to recurse. So here's where the recursion comes in. And now I'm going to show you how to call a function that returns a tuple and get its value out. So this is important little example here. So there's two ways to do it. I'm going to do it one way here, which is I'm going to let operand evaluation, which is just a local variable that I'm inventing, equal call evaluate with the remaining ops that I have. Okay, so here I've recursed. Okay, I'm recursing. And I just set it to operand evaluation. Now, let's look at the type of this thing. If I look at its type, you can see that it's a tuple. That's its type. It's a tuple, result, remaining ops. It's this tuple right here. That is the type of this operand evaluation. So now that I have that tuple, it's the result of the evaluation. How do I get the result and the remaining ops out of it? Well, I can get the operand by saying operand evaluation dot result. Okay? So that just this is the tuple. Here I'm getting this value of the tuple out of there. Now what type is this? Anybody? It's an optional. You're pretty safe saying optional when I ask what type it is, aren't you? It's almost always an optional, because I usually don't ask if it's not. But it is indeed an optional double. It's this type right here. Okay? So we need to turn it into a double if we're going to pass it to this operation right here. So I'm going to use if let to turn that into a double. Okay? Now I can actually do this because I have the operand. Just got it right here. Okay? This is now a double. See? And I can call this operation right here. And this is the remaining ops, but this has got to be the remaining ops after we recursed. So it's got to be the remaining ops in this operand evaluation. So that's operand evaluation dot remaining ops. Everybody cool with that? So that's it. Let's just recurse. We just recursed to evaluate that. If this fails, if this recursion returned nil, then if let's not going to happen, this return is not going to happen. We're going to fall all the way out and return nil, which is what we want. Okay? If we fail in any of our recursive attempts to get the operands we need, we got to fail all the way up to the top level. Okay, now binary operation. Also, okay, let's do, binary here, case, binary. Obviously, same exact thing here. We don't care about that. And here we're going to let operation. And we're going to do exactly the same thing we did here, but we just have to do it twice because we got two operands to do through here. So let's let our op1 evaluation equal evaluate with our remaining ops. Okay? And then if we can let operand 1 equal the op1 evaluation result, okay, then we got op1, that's good. So now let's let op2 evaluation equal recurse again with op1's remaining ops. Okay? And if we can let operand, if we can let operand 2 equal op2's evaluation result, then we can return a tuple which is calling the operation with the two operands. Okay? And we'll have op2's evaluation remaining ops as our remaining ops. Okay? Make sense? All right, we got an error here. What is it? Okay, yeah, so this is a good error to cover here. See, this says method must be declared private because its parameter uses a private value. And sure enough, op is private, so this has to be private. Okay? Now notice, by the way, I don't have default : break here in this switch. And why do I not have that? Because I've handled every possible value of op. Okay? There are only 3 kinds of op. I've handled them all, so I don't need any default. It wasn't like in the other one where we had a string. We only handled a few strings. We had a default break. You don't put default break in when you handle everything. And it's really bad programming style to put a default break in every single switch. Okay? You should only put them in the ones where you truly are breaking because you can't handle every case. Okay? All right. Now, the last thing we have to do is just call this recursive version from here. And I'm going to call this one and get these tuple values a little differently. I'm not going to call it in the same way here. I'm not going to say let something equal. Instead, I'm going to say let a tuple, which has, let's say, result and remainder, equal evaluate. And I'm going to pass my whole op stack here. Okay? So this is a different way to call a function that returns a tuple. Here, you actually let a tuple equal the result. Instead of letting a single thing equal result and then using the dots to get it, you let the tuple equal it. And notice that these names don't have to be the same as these names. So result is the same, but here I use the word remainder instead of the word remaining ops. Okay? They do not have to be the same. And then here, we just return our result. Okay? So we learned a lot right there. Okay? We learned about tuples, passing, things back to tuples in different ways. How to ignore things in the enums and when we're getting associated values, all that stuff. So hopefully you got all that. I see a few people still kind of catching up on their typing, so I'll break for a second here. So that's it. That's the entire implementation of our calculator brain. It wasn't really that bad, actually, right? Pretty simple little data structure here. Just have to say what our known ops are. You have this recursion, which actually is quite simple, powerful code. If you're not comfortable with recursion, I can see how it might be a little bit disturbing, but go stare at it for a while and you'll get it, how it works. Okay? So now that we've got this new calculator brain, we have to use it in our old controller. Okay? Yeah, question, sorry.
Do we have to let like the op stack equal the remainder?
Do we have to let the op stack equal the remainder? Here you mean?
Yeah.
Well, we're not going to use remainder, so actually even I could put I don't care here. I only put that remainder there to show you it could have a different name, but I'm not using the remainder. I only want the result. You see?
Won't the op stack contain what was previously in it before you evaluated?
Yes, the op stack will be unaffected by this because the op stack is an array. Arrays are passed by value, so a copy of it gets passed into here. So this would be untouched, and which is what I want. I don't want evaluate to consume my op stack. I want to be able to call evaluate over and over and over, okay? Especially if I, let's say, introduced variable operands. Hint, that's what your homework's going to be. Then I would want to change the variable to different things and be calling it over and over with different values for the variable, for example. And then maybe next week, I could have an assignment where I'm going to make you graph such a thing, which I'm going to do, okay? So that's why we want to do that. So anyway, yeah, remainder here can just be anything. I'm actually going to put this here because we're going to printlen this in a second just so we can get a better look at what's going on. But first, let's go back to our controller and use this calculator brain, this nice model we just invented. Let's use it. Now, I'm going to show you how to get two things on screen at the same time that aren't necessarily directly related. Before, we had the storyboard, and then I went up and clicked this assistant editor right here, and it showed me the controller because the assistant editor figured out, oh, if you have the storyboard up, you probably want the controller for the scene you have selected. But here it's like, oh, I don't know what to show you. So I'm going to show you a different way to get something in here. Well, two ways, actually. One is, if you go to this top bar, where it says counterparts, you can mouse down, and you can find all kinds of things about this, like subclasses of this class on the left, superclasses of this class on the left. Of course, it has no superclasses or subclasses. But other things it includes or included by it, you can also just manually go, and we could go over here, for example, and find our view controller and load it up that way. But I'm going to show you a different way than doing that, which is to go over here to your navigator. If you hold down Option and press on a file, like view controller, it will appear on the right. Okay? So Option clicking in here is another good way to put things on the right. Okay? So now here we have our calculator brain on the left, and we have our controller on the right. We are going to rip out all of the stuff in our controller that had to do with being a calculator. Okay? So that's all this stuff right in here. Okay? All this calculating stuff. We don't need any of this because those were only called from there. Okay, so our controller is getting quite simple. Our controller hardly has anything left in it, and that's because the UI only needs this to be controlled. Okay? We also don't need our operand stack because the brain is going to do that. However, we do need a new instance variable here, which is the calculator brain. Okay? And I'm just going to create one like that. This is extremely common. Okay? This is the green arrow that goes from the controller to the model. Remember that in our MVC talk that I did last time, I said that the controller has a green arrow to the model. It can talk to it all at once, say anything at once. This is essentially that green arrow. This is our model right here, and this is the controller. This is how the controller talks to it through this thing we call brain. Okay, you can call it anything you want. And of course, this might be a much more complicated green arrow. It might be a network database that it's connecting to get the data. Okay? But in our case, it's this very simple little brain. Okay, so now we don't need this either down here. This is where we're appending onto the op stack and printing it out, so we don't need that. But we do need in enter to push the operand onto the stack. Okay, so here I'm just going to say that I'm just going to say brain.push operand our display value. Okay. That's the main thing I need to do is just do that. One thing, though, is I also need to update my display. Because when I push this operand, that's going to change the brain. I need to call that evaluate, right? And get the value. So I could call evaluate here, but actually I'm going to go back to my brain, and I'm going to change push operand to return the result of evaluating. typing today, from internally. So I'm going to return evaluate here. So that every time you push an operand, it'll just return the evaluation. Now, one could argue whether this is the best thing to do, because you might not be interested in the result of evaluating that right now. But it kind of feels to me kind of good, and there's not going to be that many things on the stack. You're not going to usually have calculator brain have 1,000 operations and operands, although you could, but you're not usually going to. So it's probably not a performance issue to have it just return this. And it'll make caller's code, look a little simpler. And if they don't want this return value, then they can just ignore it. They don't have to use it. But I am going to use it. So when I push this operand right here, I'm going to if let the result equal that, okay, because it's an optional. And if it's not nil, then I'm going to set the display value to the result. So in other words, every time I push an operand, I'm going to up my display value with the evaluation. Make sense? Okay, what if this comes back nil? So I push something on. This is not going to happen probably with push operand, but it might. After your homework, it might. So what if I push it and it comes back nil? Well, now I'm kind of stuck. Okay? This is why in your homework assignment I suggested, wow, wouldn't it be cool if display value took an optional? Right? If display value took and returned an optional, you could put something sensible in the display when you had something that couldn't be evaluated. So in assignment 2, making display value into an optional is going to be a required task. So you might as well do it for homework 1, because you're going to have to do it for homework 2 anyway. Okay? Just wanted to give you more time because I didn't really teach you the things about number formatter and stuff in time for assignment 1, but it's going to be required. And that's because the best I can do here is maybe say display value equals 0. That's really lame, but that's the best I can do. I really want to say display value is nil. Okay? I really just want to set display value equal to the result of this. And I want to have nil, clear out my display. Or in assignment 2, extra credit, maybe it puts an error message in my display. Now that's extra credit, but that would be even better things to put there. Okay? But same thing for performing the operation. Here's our operation right here. And I'm just going to say if I can let the result equal brain's perform operation of the operation that I got off the button, then I'm going to let my display value equal that result. Otherwise, I'm going to do the very lame thing of saying display value equals, value equals 0. Okay? People understand why that's kind of lame? Right? Okay. So that's it. Look at how simple our controller is here. It has almost no code in it. Okay? And that's really, iOS is great about that. It really is pretty good about making so you can build your UI mostly graphically so that there's very little code to control what's going on. And then even our model, which is a pretty powerful calculator right now, we could add as many functions as we wanted to it, just with one-liners here, and it would be capable of evaluating any series of them that's evaluatable. And it's also set up to do your homework, okay, which is to add those variables, to be able to push operands that are variables. The other thing your homework is going to ask you to do is to draw this, okay, the contents of it in a human-readable form, using infix notation like this, with parentheses when necessary, things like that. And that's going to be a lot easier here too, because you can use recursion to build this as well. Okay? So that's the main 2 things of your homework. That's what they are. All right. So let's see if we broke anything here. All right. So we're going to go up here and run. See if this all still works. Our UI has not changed. You notice I never even opened the storyboard here. Didn't even open the storyboard. Okay? All these changes were pushing things out of the controller into the model. Okay? The communication between the controller and the view has not changed here. So hopefully this is going to work. Let's try 85. Our number entering is still working in our controller. That's good. Enter. Okay, it still says 85. That's good. How about 41 plus? Oh, seems to actually be working. Square root. That's also working. 9 times. Excellent. That's working. Now, what if we do something that's not evaluatable? I'm going to press times a whole bunch of times, right? Times. Oh, 0. See, that's not really great feedback, okay? But it's not really 0, but it's It's not good either. So your homework is going to be printing out what's on the stack in a nice form, so you'll be able to see that you have times, 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 and it's going to equal a blank display, and that's going to make sense that it's blank. Okay? All right. Now, I want to do one other thing here, though, just so you can really visualize what's going on, which is I want to print out, when we evaluate, I want to print out this stack. I want to print out the thing we're evaluating. I want to print out the result. And I even want to print out the remainder here so we can see what's going on. So I want to say println, and I'm going to say, I'm going to use my backslash thing here, opstack equals result with, how did I say this? With, oh yeah, with our remainder left over. Okay? So wouldn't it be cool if I could just do this? Just say, okay, the op stack evaluated equals this result with the remainder left over. Okay? Let's run that. You think that's going to work? Maybe. Let's see. Okay? So let's try putting 8 on the stack. Okay? Let's make so we can see. It's over here. Where is it? It's this probably there. There it is. We don't need that one. Okay. So here is our, okay, let's command tab, it's this. Okay, so it said here, enum value in an array equals result of optional 8, that's good, optional 8 is good, with nothing left over. Okay, that's good. Let's go 6, enter. Oh, now we have enum on the stack equals optional 6 with enum left over. Oh, that's not so good. Times, enum equals it with, this is terrible. This is, I can't understand what the heck is going on here. Why is this happening? Okay, when you put something in parentheses like this, it tries to convert it to a string. Okay, well the thing that's in here is an array. Arrays know how to convert themselves to strings. What they do is they put open square bracket, then they ask every single thing in the array, convert yourself to a string. Okay, and it puts them here. Well, our op is converting itself to this string, enum value. Okay, that's because the system doesn't really know how to convert it any other way. So it's just saying that's an enum value. It doesn't know how to convert itself to a string. So you see what's going on here? So I'm going to show you how to teach a type to turn itself into a string. Okay, because that's really valuable for debugging, and also might be valuable for your homework. So how are we going to do that? All right. The way you do that is you have to add a computed property to your type. And enums, just like structs and classes, can have properties. Okay? Only computed properties in enums, structs and classes can have properties that are values, like this over here, right? But they can only be computed. You remember a computed property looks like this, var, the name of it. It has to be called description, because it's going to be a string description of it. The type has to be string. It's a string description of it. And then, of course, you want your get here, and your get and your set. Set. But it has to not only be a computer property, this description thing, to make this work, it wants to be a read-only one. So we're not going to put the set. So there'll be no set, just a get. So this get just has to return this op as a string. So it has to somehow turn it into a string. Well, how would we turn our op into a string? Well, for the operations, we're just going to return the symbol. Okay? If this is a plus operation, turning into a string is I'm just going to return a plus, because that pretty well describes a plus operation, a plus. For the operand, I'm going to have to turn this double into a string and return that. Okay, so how am I going to do that? I'm going to do that using switch. I need to switch on myself, okay? Because I'm going to do this switch so that I can get these same things out here. I'm going to do the same thing I did here. See how I did this switch? So I could get these associated values out. I need to do the same thing here. So how do I switch on myself? I say switch self, okay? And then I just have to say the case for operand, and I'll let that be the operand. And I have to do the case for unary operation. Now, when I do the case for unary operation, I want the symbol, but I don't care about the function, because I'm not actually going to compute anything. I'm just going to return the symbol. And then for binary operations, same thing. I want the symbol, but I don't want this. So that's the don't care. And what am I going to do in each of these cases? Well, in the operand case, I'm going to return a string that is that operand. Oops. Don't like the way it puts that extra thing on there, okay? And then in the unary operation case, I'm just going to return the symbol. And in the binary operation case, I'm also just going to return the symbol. And we have, oops, don't have parentheses there. Okay, and we've covered every case of this switch. So not only does it know that this switch is covered, but it knows that we for sure have returned something out of here because we only have one expression here, which is the switch, and we know that covers every case. So there you go. So we have this nice description. Now, this is not quite enough. Okay? You have to implement this property, this computer property, read-only. But you should do one other thing, which is up here. You have to put colon printable. Now, I told you enums and structs have no inheritance. So you're like, well, wait a second there. You're telling me op inherits from printable? And the answer is no, it does not inherit. Okay, it's an enum. Enums don't have any inheritance, only classes do. What this colon printable means is, and this can be true for classes or structs or whatever, you can put after the colon here, this is called a protocol. And all this means is you're telling Swift that this enum implements whatever is in this protocol. And this protocol happens to just be one computed property called description that returns a string. Okay? Now we're going to talk about protocols in depth because protocols are very important for explaining how things work. Okay? But we're not going to cover it today though. Okay? So if you do those two things, put description and printable, now when we run, you'll see I'll go 5, enter, 6, and you see it's put a 5 in there. There's a 6, times, it's even putting the times. If I hit times again, now I get nil, and it shows me the whole thing is left over. Okay, let's go another thing here. What if I go 6, enter, 5, enter, 4, enter. Now if I do times, it says times of 4 and 5 is 20 with the 6 left over, which is exactly right. Okay? Now, notice I had to rerun there to do that. You're going to have a clear button, right, that you did in assignment 1. You're going to have to make that work in assignment 2 as well. Okay? The last thing, we're really out of time, but I'm going to show you the last thing really quickly that I was going to do is use this description to fix this problem that I said right here, which is, what if I had a function called learn op, okay, and it took an op as an argument here, and it just said known ops description equals that op. You see? Now these could all just be learn op this, okay, which is a lot nicer. I only have to type this thing once, and I just use the description here. The other thing about this, notice where this function is. Inside the init. Okay? You are allowed to put functions inside other functions. If this is only called inside here, you can put it in here. If I put it outside, in fact, I'd have a little problem because it would have to be private because it uses op. And that's what this error right here is. Right? I'd have to say private func. But I don't want to do private func. Instead, I'm just going to put this right down here. Okay, and obviously I would do that with the rest. Okay, that's it. Hope you learned a lot of stuff about Swift for that, and I will see you all on Wednesday. I'm here if you have questions.
For more, please visit us at stanford.edu.